Hey everyone, welcome to our day 17 discussion. Today we are going to discuss about the Kubernetes namespaces. In day 16, we discussed about the different types of pods, and the first pod was DaemonSet. DaemonSet, okay? And the second one we discussed is Sidecar Containers, and the third one we discussed is Jobs, and the fourth one was init container. In DaemonSet, we mentioned it is a number of nodes is directly proportional to the pods. In Sidecar Container, we discuss rather 100% workload to a single container. What we have done, we have distributed the workload into two containers. I will say C1 and C2 inside the pod only. And the third one which we discussed, jobs, is it is different from the replica set or deployment. Job was a kind of bot which was created to do some specific task and then it was completed. Okay. And finally, the fourth one which we have discussed, it is like a sidecar container only, but the difference was, I would say this one was my pod, C1 was my container and C2 was my second container and this one was my empty dir. So the first thing in init container, it would be done. Firstly, the C2 container will complete its task. Okay. And once this task is completed, then my C1 container is going to be started. So this concept is called init. So we already have a very detailed discussion in our day 16. So let's start our today's agenda. Before discussing the Kubernetes namespaces, firstly we have to discuss regarding the requests and limits. Okay. So till now, while creating the pod, have we mentioned any kind of restriction in terms of CPU and memory? The answer is no. Which means if I'm going to create a two application 1 and application 2, eventually the application 1 is going to create a pod 1 and application 2 is going to create a pod 2. I would say in this pod 1, due to some application issues, I would say if it is going to consume 100% of my node pool CPU and memory, do you think this consumption will impact the application 2 or not? The answer is yes. Why? Because eventually the pod is going to be created inside the nodes. Okay, I will say this is my pod 1 and this is my pod 2. And if this pod is going to take all the CPU and memory from the nodes, then P2 will be impacted. So to overcome this kind of situation, what we have to do, we have to implement requests and limits inside our container. So what is the exact meaning of requests? Okay, whenever we are creating our container, and while creation of the container, we want to add some CPU and memory. CPU and memory that would be allocated at the time of creation, then we need to use request concept. If I'm going to mention one CPU, then this one CPU will be allocated to my containers at the time of creation. Okay, it doesn't matter if it is going to utilize this one or not. So this is the amount of CPU which is going to be allocated to my container. Okay, in the same way we are good to allocate the memory too. Okay, in terms of limits, it would be the maximum CPU or memory container can utilize. Okay, if I'm saying My request is one CPU, which means at the creation of my container, one CPU will be allocated. And if I'm saying the limit is 2 CPU, means 2 virtual CPU. So in this case, the maximum CPU a container can consume is 21. So request is the amount of CPU and memory which is allocated at the creation time of our container. Limits is maximum amount of CPU and memory a container can utilize. Okay, so let's do a quick demo to understand both the concepts request and limits. So let me open my Visual Studio Code. In my Visual Studio Code, I have already created a folder name called as day17. We'll create a YAML file name called as request hyphen memory.yml. Okay, and the configuration is this one. As you can see here, we are trying to create a pod. The name of my pod is request-pod and there are two levels. Finally, we are creating a container. The first container name is request-container. We are using an image, and from the line number 12 to 14, we have mentioned resources. Okay. Then we have mentioned request. Request. So what is the exact meaning of request? If you are going to mention anything inside the request, it would be allocated at the creation time. And the memory which I have requested is 2 GB byte. So the concept it would be, if this is my pod, the name of my pod is request-pod, and inside this pod I'm creating a container name called as RC. I would say request container, and the image which is going to use is nginx one. At the creation of this container name called as RC, 2 GB byte of memory will be allocated. Okay, so till now what we have done, we have created a pod, eventually a container, and in this container we have not implemented any concept of request and limits. If this container wants to utilize 100% of CPU and memory of our node pool, then it can. Okay, in real-time scenarios, this process is not followed because it can impact the other application. So while creating of the pod, we need to mention the request and the limits. So let's firstly focus on the request part, and then we'll discuss about the limits. I have already created a cluster name called as demo-AKS. Okay, let me connect to my cluster. We'll open a CMD. We'll download the cluster credentials. Okay, we'll copy the path, clear the screen. So the first thing which I'm going to do, I'm going to create a pod. Okay, what I'm doing, I'm creating a pod name called as nginx, and the image is also nginx. Finally, my pod has been created. kubectl get pods, and let me describe it. kubectl describe pod nginx. If you see here in this pod containers configuration nginx, are you able to see anything related to CPU and memory? To be more precise, in terms of request or limits, the answer is no. So as we have discussed, it does not have any kind of restriction, so it can utilize the 100% amount of CPU and memory of our node pool. Okay, let me run this YAML configuration. Here, and we'll run kubectl create -f request memory.yaml. My pod has been created. I will run kubectl get pods. The pod is in running stage. Let me describe my pod. kubectl describe pod, and the name of my pod is request hyphen pod. So the name of my container is request hyphen container. This is my container name. All the other things are same. As you can see here, we have one more entry of requests, and here the memory it is mentioned. So which means at the creation time of this container, a 2 GB byte of memory is allocated. Let me create one more pod. Okay, in that pod will mention the amount of memory which is not present inside my node, and then we'll check how it is going to behave. Okay, so I'm going to create one more YAML file name called as request hyphen memory hyphen max.yml. As you can see here, we are creating a pod. The name of my pod is max hyphen memory hyphen pod. These are the labels. Then I have mentioned the container name. This is my image, and I have mentioned the memory as 9 GB byte. Okay, so in this case, at the time of creation of this pod, 9 GB byte of the memory is going to be allocated. Let me quickly check inside the portal. Do we have any nodes present with this configuration or not? So in this node pool, I have only one node pool name called as system pool, and the size of this node pool is 8 GB byte. Okay, but I have requested how much? I have requested in terms of 9 GB byte, which is greater than our node total memory. So let me run this configuration and check, is it working on. Say kubectl create hyphen f request hyphen memory hyphen max.yml. So my pod has been created. Let me run kubectl get pods. So the current status of my pod, it is showing as pending. Okay, let me describe my max hyphen memory pod. The command is kubectl describe pod, and the name is max hyphen memory hyphen pod. If you see here, we are getting an error. The error is failed scheduling. 0 nodes are available, 1 insufficient memory. So what is the exact meaning of it? As we have discussed, a scheduler is basically responsible to schedule my pod on a specific node. Okay, this is the part which we have discussed in our Kubernetes architecture. But we have mentioned request. We have mentioned request. In request, we mentioned 9 GB byte of memory. Do we have currently 9 GB byte of memory in our node? The answer is no. That's why scheduler is not able to schedule my pod on any node, and hence we are getting this error. The second part which I want to say, whenever we are going to mention anything inside the request, so memory or CPU, it would be allocated at the time of creation only. If you notice, in the first case our pod was created and it was running successfully because the memory which we have mentioned, it was available. In the second case, we tried to create a pod, but the memory which we have mentioned, it was not present inside my node. So this is the concept regarding the request memory. Okay, in the same way we are good to do for the CPU also. So most of the people are confused in terms of CPU and memory unit. Okay, I would say one CPU is equal to 1000 millicore. Okay, and if I'm going to mention 500 millicores, 500 millicores, we are good to mention it as 0.5 CPU. While in the case of memory, 1 MI is equal to 1024 kilobytes, while the case of 1 M, which is stand for megabytes, is equal to 1000 kilobytes. That's why whenever we are writing anything in terms of memory, we should write in one mi form because it is equal to 1024 KB. And in terms of CPU, if you are mentioning like 2 CPU, 3 CPU, it is fine. But if you want to mention anything below 1 CPU, we are good to mention 500 millicores or 0.5 CPU. Both of them are correct. Let me do one more demo. Okay, and the name of my YAML file is limit-check.yml. And in this configuration, if you see limits, what I have done, have I mentioned anything request? The answer is no. I have only mentioned the limits. Okay, then I have to check what is the request value it is showing. So let me firstly clear my screen. And my pod has been created. Let me describe my pod. There's one value for limits and the second value is the request. But we have only mentioned the limits only. But how this request value is updated? So the use case is, if you are going to mention only the limits, then the limits value is equal to request. Okay, so let's do a quick recap what we have discussed till now. In my first example, I only mentioned the request. So the CPU and memory, whatever I mentioned was allocated, but I haven't mentioned anything limit, so it was able to utilize the 100% of my node CPU and memory. In my second example, I mentioned request and limit. It was able to utilize mentioned values. But in third use case, I have only mentioned the limit. Okay, if you are going to mention only the limits, then limits is equal to request. Okay, so this is the thing which we need to understand. In the first use case, I mentioned the request, so that CPU or memory was assigned. The limit, it was free, it was able to utilize the 100% of my node pool. In my second example, I mentioned the request and limit, so whatever the value we mentioned, it was utilizing. In the third example, I only mentioned in terms of limits. I haven't mentioned anything regarding the request. So in that case, the limit will be equal to request. So with this, we have completed our discussion for limits and requests. So we need to discuss regarding the namespaces. Okay. So the first thing which we need to understand, why we need to have the namespace. Okay. In real-time scenario, what we are going to have, we are going to have one AKS cluster. And in this AKS cluster, we are good to deploy multiple applications. Okay. Do you think it would be good idea to deploy all the application at a same place? I would say this is my AKS cluster. Okay. Do you think this AKS cluster is going to be used by only one application? The answer is no. It would be shared among different application. I'll say one pod for application 1, the second pod for application 2, the third pod for application 3. Do you think it would be good idea to place all the three application where they are good to see the resources of each other? The answer is no. So to overcome this kind of issue, what we have to do, we have to create a namespace. So namespace is going to create a logical separation inside my AKS cluster. So for my application 1, I'm going to have application 1 namespace, same for my application 2 and same for my application 3. So in general, we are good to say resource isolation and separation. Okay, so after implementing the namespace, whatever the pod we have deployed inside the namespace 1 for our application 1, it is separate from application 2 and application 3, and same thing it is applied for application 2 and application 3. The second benefit is access control. Okay, so in this case, whoever owns this application 1, we are good to provide the application 1 namespace access. So they will only see the pod which is related to application 1. They won't be able to see any pod which is related to application 2. And same thing it is applied for application 3 too. So we are good to implement the access control. And the third benefit is resource quota and limit range. So we are going to discuss about the resource quota and limit range separately. So here comes very interesting question. So till now, where we have created our resources. So our resources have been created in a default namespace. Whenever we create our Kubernetes cluster, a default namespace is provided to us, and we are good to create all our resources in the default namespace. Okay, so let me quickly create one namespace for us. I would say ns.yml, and the kind which I have mentioned is namespace, and the name of my namespace is demo-ns. Okay, let me run a command called kubectl create-f ns.yml. And if you see kubectl get ns, our namespace has been created, name called demo-namespace. As I have mentioned, till now we are working inside this default namespace. So whatever the resources we have created till now, it is created inside the default namespace. Okay, let me describe my namespace. I'll say kubectl describe ns demo-ns. The name is this one, the label is this one, the annotation we have not mentioned, the status is active, and it is mentioned the resource quota and the limit range is not defined. I'm going to discuss about both the topics. So let me create a pod inside this namespace. As you can see here, the kind is pod, the name of my pod is demo-ns-pod, and here I am creating two containers, container 1 and container 2. But if you see in metadata, what I have mentioned demo-ns, which I have created just now. So in metadata, the first thing which we are good to mention the name. The second thing which we are good to mention is labels, and the third one which we are good to mention namespace, which means our pod will be created inside this namespace. Let me run the configuration. My pod has been created. I will run a command called kubectl get pods. Are you able to see any pod with a name called demo-ns-pod? The answer is no. Why? Because as I have mentioned, till now whatever the resources we have created, it is created inside the default namespace. Okay, and here I have mentioned kubectl get pods in the default namespace. So we have to mention a command called kubectl get pods, and what is my namespace name? My namespace name is demo-ns, and see, my pod is in running stage and both the containers are in a ready form. By default, whenever we run any configuration, I'll say kubectl get service. Okay, so it is pointing to where? It is pointing to a default namespace. And if you want to change the config, so what you have to run, the command is kubectl config set context -- current and my namespace name. Okay, after running this command If I'm going to run kubectl get pods, you see here it is listing all the pods which are present inside my demo-namespace. By default, the current context is default namespace only. That's why whenever we run our kubectl get pods or get nodes, it is pointing to my default namespace resources. So what we have done till now, we have created our Kubernetes namespace, and in this namespace we have created our own pod. Okay, and once my pod was created, I have set the context only. As I mentioned, we have a default namespace where all the resources are created. But if you have noticed, when the last time I initiated this command kubectl get ns, there are some other namespaces also. The default one is the place where we have created all our resources till today. Demo-namespace, it is created by me. Then we have the other namespaces also. Cube-node-lease, cube-public, cube-system. As we have discussed in our Kubernetes architecture, we have our master node, then we have our worker node. Okay. To run this worker node or to connect with the master node, there are some specific pods are running, and all these pods are present inside where? Inside our cube-system namespace. If I'm going to run this command kubectl get pods -n cube-system, see, there are so many pods listed. All these pods are created when we created our Kubernetes cluster, and all the system configuration related resources are present inside my cube-system. Then we have the second namespace, which is called as cube-node-lease. It is an internal Kubernetes namespace that help track node health and availability using lease object. It is not being used by any application or any user. So it is an internal namespace. And finally, we have one more namespace name called as cube-public. If you see, in cube-public namespace has the information regarding our Kubernetes cluster. If you see here, I initiated a command called kubectl cluster-information. It has the details regarding the control plane, the core DNS, and the metric server. All this information are coming from this namespace only. Okay, the name of my namespace is cube-public. So let's do a quick recap. Default is the namespace where we are creating our resources from day one. Demo-namespace, just now I created, and inside this namespace I have created the pod. The third one is cube-node-lease. It is not used by the application or user. It is for the internal user of Kubernetes. The cube-public namespace provides a metadata regarding our Kubernetes cluster. So all this information, like our control plane is running on this URL, core DNS at this path, metric server is this path, is coming from cube-public. And finally, we have cube-system where all our system configuration resources are created at the creation time of my cluster. So the next topic which we are going to discuss is resource, I would say, quota. So what is the exact meaning of resource quota? As we have discussed, we are good to create a namespace. And once we create a namespace, it provides a logical boundary within our Kubernetes cluster. But in our last example, we discussed for our pod, to be very precise, for our container, what we are using, we are mentioning limit and request. Limit is the amount of CPU and memory that would be maximum allocated to my container, and request is the default value which is going to be assigned at the creation time of my container. Okay, so in the same way, I'd say if this one is my AKS cluster, and I have namespace 1, namespace 2 and namespace 3. We have mentioned the restriction at the container level while the creation of it, but we need to mention some restriction at namespace level also. If we are not going to mention the restriction in terms of compute, storage or object, then this namespace can utilize the 100% of our nodes capacity. I would say our nodes capacity, and it can impact the other namespaces also, eventually our application. To limit the namespace utilization, we need to use what? Resource quota. Resource quota is implemented at namespace level. Okay, that's why if you noticed, when we initiated this command called kubectl describe ns demo-ns, see, it is clearly showing no resource quota, no limit range. Limit range we'll discuss about it. Let's firstly focus on resource quota, which means currently for this namespace name called as demo-ns, I have not mentioned any kind of restriction how much memory, CPU and number of objects it can create. It can utilize the 100% workload of our node pools. Okay, so to overcome this kind of scenario, so that it is not going to impact my other application, what we have to do, we have to implement resource quota at namespace level. The namespace, as I have mentioned, it can be implemented in two ways. The first one is called as resource limit. Like I want to create 3 number of pods, so only 3 number of pods will be created inside this namespace. If you are going to create the fourth pod, you are going to get the error. In the same way, we are good to put some restriction the CPU or memory part. Okay, so let's do a quick demo to understand it. Let me clear my screen. We'll create a YAML file name called as request quota.ym. As you can see here, the kind which we are trying to create is our resource quota. The name of my pod is rq-quota. I'm using the same namespace which we have created last time, and here are the request and the limits which I have mentioned. Request means by default it is going to get 2 CPU cores, 2 GB byte of memory, and the maximum it can utilize is 4 GB 4 CPUs and 3 GB byte of memory. As I have mentioned, the resource quota can be utilized in two ways. The first one is regarding the compute in terms of CPU and memory, and the second one is number of services. So I'm restricting my namespace to create only 3 pods. If I'm going to create a fourth pods, I'm going to get the error. In the same way for secrets and services. So let me run this configuration. So my resource quota has been created. Let me describe my namespace. And if you see here, my resource quota have been updated in terms of limit CPU 4. The memory is 3 GB byte. The same with pods, the number of pod which we are going to create is 3 only. Request and the request memory, by default this namespace is going to be allocated to CPU and 2 GB byte of memory, and same with secret and services. Till now what we have discussed regarding our namespace, and then we discussed about the resource quota. Resource quota is a subpart of our namespace to limit the compute based thing and the number of services. Right now what I'm going to do, let me create a pod kubectl -n demo-ns, then run the pod 1, and the image I'm going to use is nginx1. If you see here, we are getting an error. What is the error? It is mentioned error from server, pods P1 is forbidden, failed quota rq-pod must specify limits.cpu for pod 1, limits.memory for pod 1, request.cpu for pod 1, and request memory for pod 1. So the whole idea is we have created this namespace, okay, and in this namespace we have mentioned some limits, request, and the number of services which we want to create. But at the creation of our pod, have we mentioned anything regarding our limits and request? The answer is no. So whenever we are creating a pod inside the namespace where we have implemented this resource quotas, we need to mention this configuration while creating our pod, or else we'll get the error. So let me create a pod with all this configuration. If you see in this YAML configuration, we are creating a pod. The name of my pod is pod only. The namespace I have mentioned demo-ns. And in my container configuration C1, I have mentioned the request memory, the limit memory, and CPU. Okay, and let me run this configuration. You see here, my pod has been created without any error. Let me describe my, you see here, the limits and the request have been updated inside my container C1, and we are good to create our resources inside the namespace. At the namespace level, if you are implementing resource quota, then while creation of the pod, it is mandatory to mention the request and limit. If you are not going to mention the request and the limit, then you're going to get the error to mention it. And whatever the values you are going to mention in request and the limit, it should be within the namespace values. Let me create one more YAML file name called as pdcheck1.yml. Let me run this YAML configuration, kubectl apply -f and my YAML file name. My pod has been created. Let me run kubectl get pods. Let me create my next pod with a name called pdcheck2. Okay, all the things are same. Like here we are trying to create my pod 2 in a namespace demo-ns and the images and all. And while the creation of my container, I have mentioned the request and the limits. So let me apply this configuration, kubectl apply -f, my YAML name. Here we are getting an error. The error is the limited is pod is equal to 3, and we have already created 3 pods. So this pod was the 4th pod which we are trying to create. If I can describe the namespace, kubectl describe namespace, and the name is demo-ns. Here I have mentioned my number of pods which I'm good to create in this namespace is 3, and I have already created it. That's why for the 4th pod we got the error. So with this we have completed our resource quota discussion. The next topic which we need to discuss is limit range. Okay, so till now what we have discussed, we have our one AKS cluster, and this AKS cluster we are good to deploy multiple application. I would say application 1, application 2, application 3, and for each application we are good to create a dedicated namespace. And then while creation of the namespace, we need to make sure we are applying some requests and limits, and also number of object creation. So with this approach, like we are giving a specific amount of CPU and memory, this namespace can be utilized maximum, or at the creation of namespace also this amount of CPU and memory will be allocated. But the problem is, I'll say this is my namespace 1. Okay, for my application 1 I have created, and I have given 2 CPU core. Okay, overall my system capacity is 8 CPU core, but for this namespace I have given 2 CPU core as a limit. And in this namespace, if I'm going to create multiple pods, I will say pod 1, pod 2, pod 3. So chances are there a single pod can consume all the namespace, I would say CPU and memory. So to overcome this kind of issue, what we are good to mention, we are good to mention limit range, and limit range we are going to mention at the level of container. Okay, whatever the values we are going to mention inside the limit range, that would be projected to our container. And in limit range we have two values, one it is called default and the other value is called as default request. Default request is a request, the value which is going to be assigned at the creation of my container, and the default is the value which is the maximum, I would say the limit the container can utilize. Okay, so let's do a quick demo to implement the limit range. If you see here what I'm creating a limit range. The name of my limit range is limits range. The namespace is demo-ns, and in specification I have mentioned at line number 7 limits. This is the default value, this is a default request. Default request is our request which is going to be assigned to our namespace. The default is the maximum, I would say limits, the CPU and memory my container can utilize. I'm saying it again. What we have done, we have created a limit range and we are going to apply it at namespace level. At the namespace level, we have mentioned two things. First one is default, second one is default request. The default is the limits, or I would say the maximum CPU and memory any container can utilize. And the default request is the CPU and the memory which is going to be assigned for any container. If you see in this YAML configuration, we are creating a limit range. The name of my limit range is limits range. The namespace in which I'm going to be updated is demo-ns. And here I have mentioned limits. Default is the maximum limits, and default request is a request which we have discussed. Okay. So this is the maximum CPU and memory any container can utilize in this namespace. And this is the default CPU and memory which is going to be assigned to any container. So let me run this YAML configuration and then check the namespace value. As you can see here, initially we have not implemented any limit range, so it was not mentioned, but right now the default request and the default limit it is mentioned. So default request is the, if any container which is going to create inside this namespace, this is the value which they are going to get, and this is the maximum value they are good to utilize. So let me create a pod in this namespace. I will mention demo-pod.yml and this YAML configuration. As you can see here, we are creating a pod. The name of my pod is demo-pod, and this is the namespace in which it is going to be created. My container name is C1 and the image is Nginx. Let me run this YAML configuration. If you see here, my pod has been created and it is in a running. One thing I would like to say, when we created our namespace, and in this namespace, when we implemented the resource quota and then we tried to create our pod, we were getting the error. Why? Because at the namespace level, we have implemented the resource quota. So if you are going to mention the limit range also, then automatically whatever the values we have mentioned inside our limit range, it is going to assign to my pod and we are not going to get any kind of error. So let me run kubectl describe pod. My pod name is demo-pod. If you see here, in my YAML configuration, I have not mentioned anything which is related to limits and requests. Okay, I only mentioned to create my pod, but these values are coming from my limit range. And in the limit range, while creation of my limit range, I mention type container. So whatever the pods we are going to create inside this namespace, they are going to get the values from my limit range only. Let me run a command called kubectl describe ns, and the name of my ns is demo-ns. In the resource limits, we have discussed regarding the default limit and the default request. But in terms of min and max is still pending. Default request and default limit, as we have discussed, the default values which we are going to assign to any pod, if they are not going to, if they are not mentioning the limits and request at the container level. But what is maximum and minimum? Let me do a quick demo to explain it. Let me paste the configuration. If you see in this YAML configuration, we already have a detailed discussion. I have just updated this YAML file, and here I have mentioned the minimum and the maximum. So there would be two cases. The first case is we are creating a container inside this demo-namespace. If we are not going to mention anything in terms of default request and default limit, so which values is going to be assigned? The default request and limits value is going to be assigned. In case 2, we are going to mention the containers, limits and request. So the maximum value which we are good to mention is this one, and the minimum value which we are good to mention inside our pod configuration is this. So let me repeat it again. I would say the first case is inside this demo-ns, I'm creating a pod, and in my container configuration, if I'm not mentioning anything in terms of my CPU and memory utilization, so the values will be assigned from my default memory and default request. While in the case 2, while creation of my container, if I wish to mention the limits and request, the maximum value which I'm good to mention is this one, and the minimum value I'm good to mention is this one. So let me run this YAML configuration. Okay, the command is kubectl apply -f limits range dot y. So it has been configured. Let me run kubectl describe ns demo-n. So if you see here, the min and the max value is updated. So the default request and limit value is going to be assigned when in our container configuration we are not going to mention the limits and request. While in the case of max and min, if I create any container inside this demo-ns, the maximum value in terms of CPU and memory I'm good to mention like this, and the minimum value I'm good to mention like this. Okay, so let me create a pod to prove this point. I'll create a pod name as p5.yml. Okay, and in this configuration, if you see what I have mentioned in terms of CPU limits is 900 millicores, but in our limit range I have mentioned the maximum value which we are good to use at container level is only 700. So let me run this YAML configuration to check are we able to create this pod or not. I'll mention kubectl create -f p5.yml, and here we are getting an error. What is the error? It is mentioned the pod 123 which I mentioned here is forbidden. The maximum CPU per container is 700 millicores, but the limit which I have mentioned is 900 millicore. If I describe my namespace kubectl describe as demo-ns, So here I have mentioned the maximum value for my CPU is 700 millicores, but I have mentioned 900. That's why we are getting this error. So with this, we have completed our namespace discussion. So thanks a lot for watching the video. Thank you.